Properties of logs. In this video, we're going to focus on using 7 basic properties of logs. There's a separate video with proofs of these properties. So the base b for the log has to be greater than 0. The base b for the log cannot equal 1. And the number a, x, and y all have to be greater than 0. So first property is log to the base b of 1 is always equal to 0. Log of 1 is always equal to 0. Log is a fancy name for an exponent. So b raised to what power gives you 1? The exponent is going to be the answer to the problem log to the base b of 1. The exponent is going to be 0 because any number raised to the 0 power gives us 1. Second property, log to the base b of b is equal to 1 because b raised to what power will give you b is 1. Log to the base b of b to the power k is going to equal k because b to the k power will equal b to the kth power. B raised to the power log to the base b of a is equal to a. Next, we're going to talk about product property. Product property of log says log to the base b, the base does not change in using any of the properties. The base remains same. Log to the base b of a product xy is equal to log to the base b of x plus log to the base b of y. Next, quotient property. Log to the base b of x over y is equal to log to the base b of x minus log to the base b of y. Log to number 7, power property. Log to the base b of a to the power n, we can bring the exponent n in the front and multiply it with the log. So first property, log to the base b of 1 is equal to 0. Exponential equivalent is b to the power 0 is equal to 1. Next property, b to the first power is equal to b. B to the kth power will give you b to the k. B to the power log b of b, log to the base b of a is equal to a. Because logs are one-to-one function, so log to the base b of a is equal to log to the base b of a. Log to the any base, here's some examples. Log of 1, doesn't matter what the base is. The base can be any number greater than 0. It can be 1/2. It cannot equal 1. Because if the base is equal to 1, think about, you don't have a function anymore. Log to the base of 1, let's say 3. 1 raised to what power will be equal to 3? None. 1 raised to any power you can raise your 1 to, it is going to equal 1 always. So it's going to be a point, not a function anymore. So base cannot equal 1. But log of 1, regardless of the base, is equal to 0. If the base is same as the number whose log you're taking, that would be equal to 1. If your base 7 is 7 raised to what power will give you 7 squared is going to be 2. 5 raised to the power log to the base 5 of 8 would be equal to 8. Let's see which property is state the property being used to rewrite this expression. So which property was used on the left-hand side to get to this side? We see we have log with a subtraction in the middle. So we did use the quotient property here, which is log to the base 2 of 12 divided by 3. And that's going to be log to the base 2 of 4. And the answer to this problem will be 2 raised to what exponent gives you 4. It is going to equal to 2. Next, we have log of a product. And the right-hand side is sum of 2 logs with 3 and x, log of 3 and log of x. And this is product property. So the first one is quotient property. The second one is product property of logs. The third one is we have a power here, exponent here, log to the base 4, 64 to the power 1/3. And 64 can also be written as 8 square to the power 1/3. So if I simplify a little more, I can write it as 8 to the power 2/3. We can pull this all the way in the front. So that would be 2/3 log to the base 4 of 8. And that is the power rule for the logs. The exponent comes all the way in the front. It becomes a coefficient. It gets multiplied with the log. Properties of logs. So log to the base 1/5, log of 1/5 to the base 1/5. That is going to be 1/5 raised to what power gives you 1/5. That's going to be the first power. If the base and the number which log of the number that you're taking are equal, then that would be equal to 1. 0.5 raised to what power gives you 0.5 to the third power, which is going to be 3. Not a decimal, but just a 3. 8 to the power log to the base 8 of 64, that is going to equal 8 itself. Oh, that's going to be 64. You can think about simplifying it. 8, let's go ahead and simplify log to the base 8 of 64. 8 raised to what power gives you 64? Well, that's going to be 2. So answer to this log problem is going to equal 2. And 8 squared is equal to 64. So that is going to be 64. Properties of logs. Product property, we're going to practice a little more with the product property. Log of a product, xy, can be written as log of x plus log of y. Again, the base remains same on both sides. The base does not change. Could be base half, base 2/3, base 5, base 10, base e, any base to the log. Log to any base b. So here, example number 1, we have 2 separate logs with the plus in the middle. That means we can go ahead and use the product property and write it as log to the base 6 of 36, which 6 raised to what power gives you 36 is going to equal 2. Next, we have quotient property number 6. Quotient rule says if you have log of a quotient, you can write it as 2 separate logs with log of numerator minus log of denominator. So example number 2 is using that property. So log to the base 1/5 of 100 minus log to the base 1/5 of 4. So we can go ahead and use the quotient property and write it as a single log with the quotient of 104, which is log to the base 1/5 of 25. 1/5 raised to what power will give you 25? Think about it. 1/5 raised to the negative 2 power will give me 25. Because remember, if you have a negative exponent, you can flip the fraction, make the exponent positive, and that's going to equal 25. So answer to this problem will be negative 2. Using the product rule, more examples. Use the product rule to rewrite each logarithm. Assume x greater than 0. We cannot take log of 0 or log of a negative number. That's the domain restriction. So that's why we are putting the condition that x is always greater than 0, so that we don't get into trouble with the domain issues. Log to the base 4 of 3 times 7, we can write it as 2 separate logs with a plus in the middle. Log of a product can be written as sum of 2 logs. Here I have sum of 2 logs. I can write it as log of a product. So this can be written as log to the base 8 of 30. Log to the base 8 of 8x, we have log of a product. We can write it as sum of 2 logs. And to further simplify, log to the base 8 of 8 is going to equal 1. Log to the base 5 of x squared, we can think of it like x times x. So that can be written as log to the base 5 of x plus log to the base 5 of x, which can also be written as 2 times log to the base 5 of x. So we could use the product rule here, or we could use the power rule here. Both will lead us to the same answer. Using the quotient rule, now remember the quotient rule is if you have log of a quotient, we can write it as 2 separate logs. We can write it as difference of 2 logs. So log to the base 4 of 3 minus log to the base 4 of 16. So if you have log of a quotient, we can write it as difference of two logs. Now the first one we cannot simplify, but this piece, 4 raised to what power gives you 16 is 2. Log to the base 3 of 5 minus log to the base 3 of 8. Now I want to point out that log to the base 3 of 5 minus log to the base 3 of 8 is not equal to log to the base 3 of 5 over log to the base 3 of 8. It's not equal to that. It's not a quotient of two logs. It's log of a quotient, which is 5 over 8. Using the quotient rule again, we want to use the quotient rule and write it as a, condense these, write it as single log. Log to the base 5 of 6 over x. Log to the base 3 of 27 minus log to the base 3 of 5. We can simplify log to the base 3 of 27. That's going to be 3 raised to what power gives me 27 is 3 minus log to the base 3 of 5. Properties of logs, power property. Log to the base b of a number raised to an exponent, we can pull the exponent all the way in the front. Here's an example. Log to the base 5 of 25 to the 8th power. It would be so much harder to find log of this large number, and it makes my life so much easier if I can pull the 8 out in the front. And log to the base 5 of 25, we already know. 5 raised to what power gives me 25 is 2, so that's going to equal 16. Log to the base 2 of 0.5 to the power 10. Again, the exponent half to the 10th power is going to be difficult to calculate. So I'm just going to go ahead and pull the exponent out in the front. It becomes coefficient. Now log to the base 2 of half. 2 raised to what power gives you half? 2 raised to the negative 1 power is going to be half. So 10 times negative 1 is going to equal negative 10. And that's going to be our answer to second problem. More practice with the power rule. Again, the power rule, we can pull the exponent out in the front. The exponent comes all the way in the front and becomes a coefficient, multiplies with the log. Radicals are also exponents. It's 8 to the power 1/2. The 1/2 can come at the front, and it would be 1/2 log to the base b of 8. Again, here x to the 4th power, 7th root of x to the 4th power can be written as a radical, can be written as a rational exponent, and the exponent comes all the way in the front. And that's the power rule. Write the logarithmic expression as a single log. So we have log difference of two logs. We can use the quotient property here, 324 over 2, which is going to be, it's not going to be 324 over 2 because this 2 is going to become the exponent. So it's 324 divided by 4, which is 81. So log to the base 3 of 81. And 3 raised to what power gives you 81 is 4. 3 to the 4th power gives you 81, so it's going to equal 4. If we were to write it as a single log and not to simplify it, we would leave it at this point. Before we discuss change of base formula, let's quickly discuss the types of logs we will be dealing with. So we'll have log to any base b of a number x. The base b has to be greater than 0. B cannot equal 1. And then the other type of log we use is log to the base 10. This is called common log. Log to the base 10 is called the common log. Normally, when we have the base 10, we don't write the base. So if you see a log of x with no base written, that means the base is 10. Okay. The other type of log we will see is log to the base e of any number x, and e is approximately 2.7. This is called natural log. Most of the calculators have common log on them and natural log on them. Some calculators do not have log to any base b. Some calculators do. So if your calculator does not have log to any base b, we can use change of base formula. And I also want to discuss the domain of a log function. Let's first look at the change of base formula. So change of base formula says if you have log to the base b of a, we can write it using any base k. It would be equal to log of a to the base k divided by log of b to the base k. So if I want to write it using base 10, it would be log of a over log of b, or natural log of a over natural log of b. For example, if my calculator does not have a button for log to the base 2, and I want to find log to the base 2 of 6, I need to think about 2 raised to what power gives me 6. It is going to be 2 point something. I know that because 2 raised to the 2 power is 4, and 2 raised to the third power is 8. So it's between 2 and 3, but it's going to be decimal. So to find it, we can use a calculator unless I want to multiply a bunch of decimal and keep trying until I get a number equal to 6 by raising 2 to decimal exponents. So we can write it as a common log. That would be log of 6 over log of 2. Or we can use it as a natural log of 6 divided by natural log of 2. Or we can use log to any base b for it. We can write it using log to the base 3. Log to the base 3 of 6, log to the base 3 of 2. We can also write it using log to the base 5, log to the base half. Any of those would be okay to use. But to make your life simpler, these are the two that are most commonly used in terms of, using the calculator. They make our life a little simpler because there's buttons for common log and natural log. Really quick, I want to discuss domain of a log function, review domain of a log function. So log of a negative number and log of 0 is not possible. We can only take log of a positive number only. For example, if I have log to the base 2 of 8. 2 raised to what power gives me 8? Well, that's going to be 3. 2 to the third power is 8. How about log to the base 2 of negative 8? 2 raised to what power gives me negative 8? Does 2 to the third power give me... 2 to the negative third power is actually, it gives me 1 over 8. It does not give me negative 8. So this one is not possible. There's no exponent that we can raise 2 to make it equal to negative 8. In the same way, there's no exponent that I can raise 2 to make it equal to 0. So log of a 0 or log of a negative number is not possible. Anytime we have log to the base b of x, we want to make sure the base b is greater than 0, b is not equal to 1, and x is greater than 0. That was all for this video.